Look down. Look at the floor beneath your feet. Feel its sturdiness, its quiet support. It is the foundation of your room, the base of your house, the ground upon which your entire world is built. It is solid. It is dependable. It is real. And it is a lie. Not a malicious lie. Not a deception crafted with intent. It is a gentle, comforting lie whispered to you by your senses every moment of your existence. It is the illusion of stillness, the myth of permanence, the profound misunderstanding that you're standing on something static. Because beneath that floor, beneath the concrete and the soil and the bedrock, there is a fire. Not a simple fire of wood and oxygen, but a fire of planetary scale. A heat so immense it turns rock into a slow, glowing river. A pressure so vast it could crush mountains into diamonds. This is the Earth's secret, the quiet truth it holds in its heart. You do not live on a solid ball of rock. You live on an eggshell, a fragile, impossibly thin crust of cooled stone floating on an ocean of incandescent magma, a sea of fire thousands of miles deep. And sometimes that ocean awakens. Sometimes it remembers the surface. Sometimes it reaches up and speaks. We have given this voice a name. We call it a volcano. But what is it truly? Is it just a geological feature? A mountain that spits fire? Or is it something more? Is it a window into the planet's very soul? A raw, unfiltered message from the deep, creative violence that forged the world? A reminder that the ground beneath us is not ground at all, but merely a temporary skin on a living, breathing, and unimaginably powerful being. Tonight, we journey into that fire. We will peel back the illusion of solid ground and float on that molten sea. We will listen not to the calming reassurances of the surface, but to the deep, slow, and terrifyingly beautiful heartbeat of the world. We will seek to understand the mystery of magma. The story of our world, as we once told it, was a simple one. It was a story of stability. The continents were fixed, immovable anchors in the great blue of the oceans. The mountains were ancient, eternal pillars, raised by a divine hand at the dawn of time and left to weather the ages. The ground was, for all intents and purposes, a finished thing, a completed creation. This was the bedrock of our perception, terra firma, solid earth, the one certainty in a fleeting world. We built our homes upon it, our cities, our empires, our entire understanding of our place in the cosmos. We were the transient inhabitants of an immutable stage. But this certainty was a mirage, a story we told ourselves because the truth was too vast, too slow, and too strange for our senses to grasp. The truth is that the stage itself is alive. The stage is the main character in the play. The first hint of this deeper reality came not as a roar, but as a quiet observation, a dismantling of our most cherished illusion, the lie of solidity. We look at a mountain of granite and see the very definition of strength and permanence. We touch its rough surface and feel an unyielding mass. But what are we actually touching? If you could zoom in past the scale of your own hands, past the grains of rock, you would find crystals. And within those crystals, you would find atoms. And the atoms themselves, the fundamental building blocks of this supposedly solid mountain, are almost entirely empty space. A nucleus of unimaginable density surrounded by a cloud of near-weightless electrons, whirring in the void. The solidity you feel is not solidity at all. It is a field of force, an electromagnetic repulsion between the electron clouds in your fingertips and the electron clouds in the rock. You are not touching the mountain. You are being held at a distance by an invisible ghost of energy. You are pushing against a force field, and it is pushing back. The entire planet is built on this principle, an immense collection of atomic ghosts, bound together by forces we are only beginning to comprehend. And these bonds are not eternal. They can be broken. All it takes is enough energy, enough heat. And the Earth has heat, an impossible amount of it. There is the primordial heat left over from its very formation, a fiery memory of cosmic collisions and gravitational collapse 4.5 billion years ago. And there is the constant, steady heat generated by the decay of radioactive elements deep within its core, a slow nuclear furnace that has been burning since the beginning. This colossal engine of heat is what melts the deep rock. It is what breaks the bonds of solidity. It transforms the planet's interior from a rigid crystal lattice into a viscous, fluid, ever-churning sea of magma. This is the first layer of truth. The ground is not solid. It is a crust. It is a scab. It is a collection of cooled, floating rafts on a world that is liquid fire below. The world you think you know is just the surface. It is the foam on a very deep and very old ocean. In the story of that ocean, the story of how we came to understand its currents and its power, is the story of a revolution in human thought. It is the story of how we learned to read the planet's own language. To understand this shift, you must transport yourself back in time. Imagine a world lit by gas lamps and powered by steam. A world where science was still entangled with theology, where the age of the earth was measured not in billions of years, but in the few thousands calculated from Scripture. The prevailing view, catastrophism, held that the world's features, its mountains, its canyons, its great valleys, were shaped by singular, violent, biblical events. The Great Flood was not a myth. It was the primary geological force. In this world, the Earth did not have a deep history. It had a brief and dramatic one. It was created, flooded, and then settled into the form we saw. The processes that shaped it were not the ones we see today. They were grander, faster, and they were over. Into this intellectual landscape walked a man named James Hutton, a Scottish physician and farmer. He was not a traditional geologist. He was a man of the soil, a man who watched the land with a patient eye. He saw the rain wash soil from his fields. He saw the rivers carve their slow paths through the stone. He looked at the rocks of his native land, at places like Sitkar Point, and he saw something that shattered the conventional wisdom of his time. He saw layers of sandstone laid down horizontally, the compressed sediment of some ancient seabed. But beneath them, tilted almost vertically, were other layers of older rock, graywacke and shale. There was a violent disjunction between them, an abyss in time. Hutton realized what he was looking at. The lower rocks had been laid down, hardened, then tilted by some immense force, then eroded away to a flat plain. Then, the sea had returned, and new sediments had been laid down on top of the old, which in turn hardened into rock. The chain of events was clear, but the time it would take was not. To deposit sediment, to turn it to stone, to lift and buckle it, to wear it down to nothing, and then to start the process all over again. This could not happen in a few thousand years. This required a span of time so vast, it was almost unimaginable. In that cliffside, Hutton saw what he famously described as no vestige of a beginning, no prospect of an end. He saw, for the first time, the true depth of geological time. He proposed a radical new idea, that the Earth was shaped by the same slow, relentless processes we can see happening today. The rain, the wind, the rivers, the slow upheaval of land. This idea, uniformitarianism, was heresy. It suggested the Earth was not a static creation, but a dynamic, constantly changing system. It gave the planet a history, a deep, slow, and epic autobiography written in the language of stone. Hutton was the visionary who gave us the gift of deep time. But even he could not explain the engine driving these immense changes. What force was powerful enough to tilt seabeds into mountains? What heat was great enough to forge the granite and basalt he saw intruding into the older rocks? The why remained a ghost in the machine. More than a century later, another visionary, a German meteorologist named Alfred Wegener, looked at a map of the world and saw something a child might notice. He saw that the coastline of South America seemed to fit perfectly into the coastline of Africa. It was like a giant jigsaw puzzle. He went further. He found fossils of the same land-dwelling reptiles in both South America and Africa. He found evidence of ancient glaciers in the tropics and coal deposits from lush forests in the Arctic. The evidence was overwhelming. The continents, he proposed, must have once been joined together in a single supercontinent, which he called Pangaea, and they had drifted apart. The continents were moving. The scientific establishment of the 1920s and 30s met his idea with ridicule. What force could possibly move a continent? The very notion was absurd. Wegener was an outsider, a meteorologist dabbling in geology, and his grand theory of continental drift was dismissed as a fever dream. He died on an expedition in Greenland, his theories still confined to the fringes of science. He had seen the what, but like Hutton, he could not provide the why. The answer, the great unifying theory, had to wait for technology to catch up with intuition. It came from the darkness of the ocean floor. In the 1950s and 60s, during the Cold War, naval ships crisscrossed the oceans, mapping the seabed with magnetometers to hunt for submarines. They found something utterly unexpected. They discovered a colossal mountain range running down the center of the Atlantic Ocean, a scar wrapping around the entire globe like the seam on a baseball. And this mountain range was volcanic. It was actively bleeding new crust onto the ocean floor. Scientists found that the seafloor was like a giant magnetic tape recorder. As lava erupted and cooled, magnetic minerals within the rock aligned with the Earth's magnetic field at the time. They discovered that the Earth's magnetic field periodically reverses, and these reversals were recorded in symmetrical stripes of rock on either side of the mid-ocean ridge. The picture snapped into focus. The seafloor was spreading. The Earth's crust was not a single solid shell. It was broken into a mosaic of enormous, rigid plates. And these plates were moving. They were being pushed apart at mid-ocean ridges, where new crust was born from upwelling magma. And elsewhere, they were colliding. This was the theory of plate tectonics, the why that Wegener had been missing. The continents weren't drifting through the ocean crust. They were passengers on these massive tectonic plates, which were floating and sliding over the hot, plastic layer of the upper mantle, the asthenosphere. It explained everything. It explained why earthquakes and volcanoes occurred in specific, narrow bands around the world. They were at the boundaries of these plates. Where plates pulled apart, you had gentle, effusive volcanism. Where they collided, one plate would often be forced to dive beneath the other in a process called subduction. This diving plate would carry water down into the hot mantle, causing the rock to melt and generating the explosive, violent volcanoes that formed the ring of fire around the Pacific Ocean. It was a beautiful, elegant theory. It was the geological equivalent of Darwin's theory of evolution, a single idea that suddenly made sense of a million disparate facts. But like all great theories, it did not answer every question. In fact, it created new, deeper paradoxes. If volcanoes only happened at plate boundaries, then what was Hawaii? A chain of volcanic islands sitting right in the middle of the Pacific Plate, thousands of miles from any boundary. What was Yellowstone? A vast volcanic system in the heart of the North American continent. And why were some volcanoes so gentle, producing languid rivers of lava, while others, like Mount St. Helens or Vesuvius, exploded with the force of nuclear weapons? The elegant machine of plate tectonics was missing a few crucial gears. There was another force at play, another kind of fire. The story was not yet complete. To understand these paradoxes, we have to look deeper into the very nature of the magma itself. We must learn its language, its moods, its strange and varied personality. To speak of magma is to speak of a single substance, but that is a simplification. Magma is not one thing. It is a spectrum. It is a family of molten materials with different chemistries, different temperatures, and profoundly different personalities. To understand a volcano, you must first understand the character of the fire that feeds it. Imagine, first, the blood of the earth in its purest, most primal form. This is basaltic magma. It is born deep within the mantle, from the partial melting of a rock called peridotite. It is incredibly hot, reaching temperatures over 1,200 degrees Celsius. And because of this heat and its specific chemical makeup, low in a substance called silica, it is fluid. It flows like hot honey or syrup. It is dark, almost black, rich in iron and magnesium. This is the magma of creation. This is the magma that builds worlds. When basaltic magma reaches the surface, it does so gently. The gases dissolved within it can escape easily from its fluid body, like bubbles rising from a glass of soda. So it does not explode. It pours. It fountains. It floods. It creates the great shield volcanoes, like those in Hawaii, which are not steep cones but vast, gently sloping domes built up over millennia by countless layers of solidified lava flows. It creates the mid-ocean ridges, the largest volcanic feature on the planet, constantly paving the seafloor with new crust. Basaltic magma is the planet's quiet, steady, constructive breath. It is the architect of the planet's foundations. Now, imagine a different kind of fire. This is rhyolitic magma. It is the polar opposite of basalt. It forms at much shallower depths, often from the melting of continental crust itself. It is cooler, relatively speaking, perhaps only 700 or 800 degrees Celsius. And it is incredibly rich in silica. This high silica content makes it not a fluid, but a thick, sticky, viscous paste. It is like cold molasses or semi-solid tar. Because it is so thick, the gases dissolved within it cannot escape. As this magma rises towards the surface and the pressure drops, these trapped gases, water vapor, carbon dioxide, expand violently. The thick, pasty magma resists this expansion, building up pressure to an almost unimaginable degree. It is a time bomb. When the strength of the overlying rock can no longer contain it, it does not flow. It detonates. The result is not a lava flow. It is a cataclysm. The magma is torn apart into a searing hot cloud of gas, ash, and pulverized rock called a pyroclastic flow, which can travel at hundreds of miles per hour, incinerating everything in its path. Rhyolitic magma is the agent of destruction. It is responsible for the most powerful eruptions on Earth, the supervolcanoes that can alter the global climate and threaten civilization itself. It is the planet's furious, explosive roar. And between these two extremes, between the gentle creator and the violent destroyer, there is a middle ground. There is andesitic magma, named for the Andes Mountains where it is common. It has an intermediate composition, intermediate temperature, and intermediate viscosity. It can sometimes flow, and it can sometimes explode. It builds the classic steep-sided composite volcanoes or stratovolcanoes that we picture in our minds. Mount Fuji, Mount Rainier, Vesuvius. These are the most treacherous of volcanoes because their behavior is unpredictable. They can lie dormant for centuries, lulling civilizations into a false sense of security before awakening in a paroxysm of ash and fire. The character of the volcano is a direct reflection of the character of its magma. The taxonomy of eruption is a taxonomy of molten rock. But what dictates which type of magma forms where? This question leads us back to the grand, silent machinery of plate tectonics, the unseen rules that govern the deep earth. The type of fire is determined by the geological stage upon which it is summoned. Consider the mid-ocean ridges. Here, two tectonic plates are pulling apart, creating a rift, a wound in the planet's crust. The pressure is released on the hot mantle rock below, causing it to partially melt. This process, called decompression melting, generates vast quantities of basaltic magma. It rises, fills the gap, and solidifies, creating new oceanic crust. It is a simple, elegant, and continuous process, a planetary conveyor belt of creation. Now consider a subduction zone like the one that encircles the Pacific Ocean. Here, two plates are colliding. A dense oceanic plate is forced to bend and plunge beneath a lighter continental plate. As this oceanic plate descends, it heats up, but more importantly, it carries with it water, trapped in the minerals of the seafloor crust. At a depth of around 100 kilometers, the heat and pressure squeeze this water out. The water rises into the overlying mantle wedge, and it does something remarkable. It lowers the melting point of the mantle rock. This is called flux melting. It is like adding salt to ice to make it melt. This process generates magma that is different from the basalt of the ridges. As this magma rises through the thick continental crust, it melts and incorporates some of that crust, becoming richer in silica. It becomes andesitic, or in some cases, even rhyolitic. This is why the volcanoes of the Ring of Fire are so explosive. They are the product of this complex, violent process of recycling and contamination. They are the fiery byproduct of one plate consuming another. So we have the rules. The pulling apart of plates creates gentle, basaltic fire. The collision and consumption of plates creates violent, andesitic and rhyolitic fire. It is a powerful explanation. But how do we know? How can we be sure of these processes happening hundreds of kilometers beneath our feet, in a realm of heat and pressure we can never visit? We know because we have learned to see the invisible. We have developed ways to probe the deep earth, not with eyes, but with other senses. Our primary tool is the earthquake. Every time the Earth's crust fractures and shifts, it sends out seismic waves, vibrations that travel through the entire planet. We have dotted the globe with sensitive instruments called seismographs, which act as a planetary stethoscope. These seismic waves behave differently depending on the material they travel through. They slow down when they pass through hotter, softer, or molten rock. They speed up through colder, more rigid rock. By measuring the arrival times of waves from a single earthquake at thousands of stations around the world, scientists can build a three-dimensional map of the Earth's interior. It is a process called seismic tomography, a CAT scan of the planet. The images are blurry, like an out-of-focus photograph, but they are revelatory. They show us the shadows on the wall of Plato's cave. We can see the great slabs of cold, dense oceanic plates plunging deep into the mantle at subduction zones. We can see the vast, hot upwellings of softer rock beneath the mid-ocean ridges. We see the blurry outlines of magma chambers, the reservoirs of molten rock slumbering a few kilometers beneath active volcanoes. We are listening to the planet's vibrations and translating them into a picture of its hidden anatomy. Sometimes, the Earth sends us a more direct message. Sometimes, an erupting volcano will act as a violent elevator, carrying pieces of the deep Earth up to the surface with it. These are called xenoliths, a word that means foreign rocks. They are chunks of the mantle, torn from the walls of the magma's conduit as it ascended. When we find a dense, olive-green xenolith of peridotite embedded in a black lava flow, we are holding a piece of the mantle in our hands. It is a direct sample from a place we can never go. It is a letter from the underworld, confirming the tales our seismic waves have been telling us. Through these indirect methods, these shadows, these echoes, these captured fragments, we have built a remarkably detailed picture of the Earth's engine. But this picture, as we have seen, contains anomalies. It contains ghosts that haunt the elegant machine of plate tectonics. These paradoxes force us to look beyond the established rules and confront phenomena that are far stranger and far more unsettling. There are volcanoes, and then there are volcanoes. The ones that live in our imagination are mountains. Cones of ash and rock, standing proud against the skyline. They're features you can point to. But there's another kind of volcano, a monster of a different scale altogether. It is a creature so vast that you could live your entire life inside it and never know you were there. This is the supervolcano. The name itself feels like something from a disaster movie, but it is a genuine geological classification. A supereruption is defined as one that ejects more than 1,000 cubic kilometers of material. That is enough to bury an entire continent in ash. An eruption of this magnitude has not happened in recorded human history. And that is a very, very good thing. Unlike a typical volcano, a supervolcano does not build mountains. The sheer volume of magma is too great. Instead of being focused through a central vent, the magma pools in enormous, shallow chambers, sometimes dozens of kilometers across, just a few kilometers beneath the surface. The pressure builds, causing the ground above to swell like a great planetary blister. When the eruption finally happens, the roof of the magma chamber collapses, leaving behind a vast depression in the ground called a caldera. The eruption itself is not a fountain of lava. It is the apocalypse. It is a column of ash and gas that punches tens of kilometers into the stratosphere, blocking out the sun and triggering a volcanic winter that can last for years, even decades. It is a pyroclastic flow of such size, it can scorch thousands of square kilometers of land in minutes. The last known supereruption was Mount Toba in Indonesia, about 74,000 years ago. It plunged the Earth into a severe cold spell and may have pushed early humanity to the very brink of extinction. And where are these sleeping titans today? One of the most famous is lying dormant, but restlessly, right under the feet of millions of tourists every year. Yellowstone National Park. The geysers, the hot springs, the bubbling mud pots. These are not just curiosities. They're the vents of a colossal volcanic system. The entire park is a giant caldera, the scar from the last supereruption 640,000 years ago. Seismographs show a vast, double-chambered body of magma still simmering beneath it. It breathes. The ground at Yellowstone swells and subsides in a slow, steady rhythm. This is the spooky phenomenon, the monster hiding in plain sight. It operates on a timescale so long that it defies human comprehension. Its heart beats once every few 100,000 years. Its quietest exhalations create some of the most beautiful landscapes on Earth, while its full-throated roar would mean the end of the world as we know it. It is a profound reminder of the scale of forces that operate beneath us, utterly indifferent to our existence. And this leads to the second, deeper paradox. What creates a place like Yellowstone or Hawaii? These are not at plate boundaries. They are in the middle of plates. The elegant rules of plate tectonics, the neat divisions of creation at ridges and destruction at subduction zones, break down here. These features seem to violate the fundamental laws of the system. The theory that emerged to explain them is strange and beautiful. It proposes that these are not products of the shallow dance of the plates. They are products of something much deeper, something rising from the very bottom of the mantle, from the boundary with the liquid iron outer core, nearly 3,000 kilometers down. These are mantle plumes. Imagine a column of unusually hot, buoyant rock, anchored in the deep mantle, rising slowly through the millennia like a blob in a lava lamp. When this plume head reaches the base of the lithosphere, it flattens out, melting vast quantities of rock and creating enormous volcanic provinces. The initial eruption can be a flood basalt event, pouring out millions of cubic kilometers of lava. Then a steady, narrow tail continues to rise from the deep mantle, creating a persistent hotspot. The tectonic plate above this hotspot continues to move, like a piece of paper being slowly dragged over a stationary candle flame. As the plate moves, the hotspot punches a series of volcanoes through it. This is the origin of the Hawaiian island chain. The Big Island is currently active, sitting directly over the hotspot. To the northwest, the islands get progressively older, more eroded, and volcanically dead. They form a perfect timeline, a dotted line of fire written across the floor of the Pacific Ocean, recording the motion of the plate over the fixed plume. Mantle plumes represent a rebellion. They are a different circulatory system for the planet. While plate tectonics governs the cool, rigid surface, plumes are a message from the hot, chaotic, deep interior. They violate the classical laws of surface geology because they are not part of that system. They are an intrusion from another world, a deeper world within our own. And this brings us to the most profound challenge of all, the role of the observer. We, with our lifespans of decades, are trying to comprehend a being whose life is measured in eons. We see a mountain and we call it eternal, but from the planet's perspective, a mountain range is a fleeting wrinkle, rising and falling like a wave on the ocean. Our perception of time is the ultimate illusion. We stand on the bank of the river of geological history and see only the still water at our feet. We cannot perceive the current. We see the world in a series of snapshots, a quiet forest, a peaceful coastline, a dormant volcano. We collapse the immense, slow waveform of planetary change into a single, seemingly stable moment, our present. To study geology, to truly understand a volcano, is to attempt an act of profound empathy. It is to try and shed our own timescale and adopt the planet's. To see a simple rock not as an object, but as a verb. It is a moment of cooling, a moment of pressure, a moment of transport, a moment of erosion. To see a volcano not as a place, but as a process, an event, a temporary opening between two worlds. When we look at the Earth this way, the distinction between safe and dangerous, stable and unstable, begins to dissolve. There's only change. There's only the slow, unending cycle of creation and destruction, of fire and rock, of breathing in and breathing out. And we are, for a brief moment, privileged to be conscious observers of it all. What does any of this mean for you? You, a being of soft flesh and fragile bone, living out a fleeting life on this thin, shifting crust. It is easy to feel small and insignificant in the face of such immense, impersonal forces. It is easy to feel disconnected from the slow, fiery heart of the world. But that feeling of separation is another illusion. Perhaps the greatest illusion of all. The boundary between your body and the body of the planet is not as solid as you think. Consider the iron in your blood. The atoms of iron that bind to oxygen and carry life to every cell in your body. Where do they come from? They were not created on Earth. They were forged in the heart of a dying star billions of years ago in a supernova explosion that seeded the cosmos with heavy elements. Those atoms became part of the nebular cloud that condensed to form our solar system. During the Earth's formation, the heaviest elements, like iron, sank to the center, forming the planet's dense, molten core. But not all of it. Through the violent, churning convection of the mantle, through the relentless engine of volcanism, this deep Earth material has been dredged up and brought to the surface for billions of years. The iron in the soil, absorbed by plants, eaten by animals, and eventually finding its way to you, is part of this planetary cycle. You're not just living on the Earth. The Earth is living in you. The fire of a long-dead star and the fire of the planet's core are fused together in the very substance of your being. You are built from the same stuff as the volcanoes. The calcium in your bones, the potassium in your nerves, the carbon that forms the basis of your organic chemistry. These are the elements of rock and magma and volcanic gas. We are, in the most literal sense, children of the Earth's fire. We are walking, talking, thinking arrangements of volcanic dust, animated for a short time by a spark of consciousness. This realization forces us to redefine our most basic concepts. What is reality? What is solid ground? What is home? We build our cities on slabs of continental crust, believing them to be firm foundations. But those continents are afloat. They are drifting, colliding, tearing themselves apart on a timescale we cannot perceive. To build a house on the coast of California is to build on the edge of a slow-motion car crash between the Pacific and North American plates. To build a city like Naples in the shadow of Vesuvius is to live in the throat of a sleeping giant. Solid ground is a temporary agreement. It is a moment of cooling. It is a state of matter, not a permanent truth. The reality of our world is fluid. It is dynamic. It is a place of constant, profound, and powerful change. Our perception of stability is a function of our own brief existence. We are like mayflies dancing for a day on the surface of a glacier, convinced the ice is eternal. This could be a terrifying thought. The idea that the very ground is not dependable, that our civilizations are built on a fragile raft, at the mercy of forces we can neither predict with certainty nor ever hope to control. But it can also be liberating. It connects us to the world in a way that is deeper and more intimate than the illusion of separation. It means we are not alien visitors on a dead rock. We are an integral part of a living, breathing system. And this leads to the most speculative leap of all. Is it possible that the Earth itself, as a system, exhibits a kind of awareness? Not a consciousness like our own, not a thinking, feeling mind, but something else. A complex, self-regulating network of feedback loops so intricate that it maintains the conditions for life over geological eons. This is the heart of the Gaia hypothesis. The idea that the biosphere, the atmosphere, the oceans, and the geology of the Earth are not separate systems, but a tightly coupled, evolving entity. Volcanoes are a crucial organ in this Gaian body. They are not random acts of violence. They are the planet's regulatory system. They vent the Earth's internal heat, preventing the core from overheating. They release gases like carbon dioxide, which traps heat in the atmosphere, and sulfur dioxide, which reflects sunlight and cools it. Over millions of years, this volcanic breathing has helped to regulate the planet's climate, keeping it within the narrow habitable zone. Volcanic ash weathers into the most fertile soil on the planet, renewing the land. The creation of new crust at ridges and the recycling of old crust at subduction zones is part of a planetary metabolism, a slow, deep chemical exchange. Is this just physics and chemistry? Of course. But perhaps that is what life is. Perhaps that is what consciousness is, an emergent property of sufficiently complex physics and chemistry. Our own consciousness is an emergent property of the electrochemical firings of 100 billion neurons. Why should we assume that consciousness is limited to the biological? Could a planet, over 4.5 billion years, develop a form of systemic, non-biological awareness? A planetary mind whose thoughts are mountain ranges and whose breaths are volcanic eruptions. It is a radical thought, but to stand before an erupting volcano, to feel the ground tremble, to see the raw power of creation and destruction made manifest, is to feel that you are in the presence of something more than just geology. You are in the presence of a primary force. You are witnessing the planet speaking in its native tongue. And our own fleeting human consciousness is a product of this planetary cradle. We're the planet's nervous system. We're the part of the Gaian body that has, for a brief moment, woken up and has tried to understand the whole. We're the Earth's way of knowing itself. So we return to where we began, to the ground beneath our feet and the fire that burns below. We return to the central question. What is a volcano? Is it a monster? A threat? A destructive anomaly in an otherwise peaceful world? After this journey, perhaps we can see it differently. After peeling back the illusion of solidity, after traveling through deep time and descending into the molten heart of the world, the answer changes. A volcano is not an anomaly. It is the norm. The quiet, cool surface of the Earth is the true anomaly. It is the exception. The natural state of matter at the heart of our world is fire. Molten, fluid, creative. A volcano is not purely a destroyer. For every city it has buried, it has built 1,000 times more land from the sea. The Hawaiian Islands, Japan, Indonesia, entire nations owe their existence to volcanic fire. The ash that can choke the skies also creates the richest soils, the foundation of agriculture. The gases that can poison the air also formed our primordial atmosphere and our oceans. Without volcanoes, the Earth would be a dead, flat, waterless world. A volcano is not a threat to the planet. It is the planet's own mechanism of healing and renewal. It is the lifeblood made visible. The scars it leaves are the price of living on a dynamic world. It is the architect, the farmer, the climate regulator, the engine of all geology. So what is it then? What is this fire? It is a pulse. It is the rhythm of a deep and ancient heart, beating on a scale we can barely imagine. It is the planet's voice, singing a song of its own creation. It is the poetry of the cosmos, written in lines of fire and stone. It is a whisper from the beginning of time. So the next time you feel the Earth tremble, ever so slightly, the next time you see a plume of steam rising from a distant peak, or see the dark, volcanic rock of an ancient lava flow, do not think of it as just a geological process. Think of it as a breath. The Earth is breathing, and for a miraculous, fleeting moment, you are here to witness it. You are not just an observer on this planet. You are a part of it. Your own breath is mixed with its atmosphere. Your own body is forged from its rock and fire. The slow, deep rumble of the world is not the sound of a distant threat. It is the sound of your own, true, planetary home. It is a reminder that you are alive and conscious on a world that is, in its own profound and mysterious way, alive as well. Feel that gentle rumble. It is not an ending. It is a beginning. It is the steady, quiet, powerful song of a world that is forever making itself new. Listen, it is singing to you.